My goal with this recording is to review your skills check, to show you how to answer questions, the frame of mind you should be in, how to use your practical reasoning along with your statistical reasoning. So let's get started. So in question 1, your goal was just to identify the population that the sample represents. I think this phrase, as precisely as possible, made some of us think that we really had to be detailed about this. And you do, but you don't want to give too much detail or start to insert characteristics of the population that may not be so. So let's take a look at the first one. An insurance company wants to monitor the quality of its procedures for handling loss claims from its auto insurance policyholders. Each month, the company selects an SRS of all auto insurance claims filed that month to examine them for accuracy and promptness. Now, what you want to understand about this problem is the difference between the sample and the population. The population is the entire group of interest. Who or what do we care about? Who or what are we trying to draw some conclusion about? So in this case, the sample would be a smaller part of that group that we care about. So what you want to do is take a look at where they pull the sample from. Who does that sample represent? So I've highlighted some details in Part A. This company is interested in monitoring the quality of its procedures for handling claims, not its procedures for handling policyholders. Also, you'll see that they took an SRS of all auto insurance claims, not an SRS of the policies. So in this case, the population of interest is all auto claims for this company filed in that month, because they only chose the SRS from that particular group. So I also highlight here, filed that month. Now let's go on to Part B. A college admissions officer wants to know what the most important factors are that high school seniors consider when they choose where to apply to college. She conducts a telephone survey with a simple random sample of all applicants to her college. Now, I understand that there's a lot of information in here, like we talked about high school seniors, we talked about the fact that she conducted a telephone survey, but don't forget the point of the question. The point of the question is to identify the population. It doesn't matter that she chose a telephone survey to ask the question, what is the population of interest? And if we look right here, her sample was of all applicants to her college. And so therefore the population is all applicants to this college. Okay, question number 2. We had a goal to identify the type of bias involved in this situation, also to state whether we think the sample percent that was actually obtained through this survey was higher or lower than that would be in the true population. Now, the scenario is this: a church group interested in promoting volunteerism in a community chooses an SRS of 200 community addresses and sends members to visit these addresses during weekday working hours to inquire about the residents' attitudes toward volunteer work. 60% of all respondents say that they would be willing to donate at least an hour a week to some volunteer organization. Bias is present in this sample design. So what we're going to think about is what happened here. And there's 2 schools of thought that I think will help answer this question correctly. The first one deals with the fact that we are visiting during workday hours, weekday and working hours. And so what might happen there? And this is where you want your practical sense to come into play. If I am going to neighborhoods on weekdays during working hours and people are answering the door, why are they home? Why are they willing to volunteer? Who didn't I ask? Would they be willing to volunteer? These are questions that should go on inside your head. And so if we think about it practically, we can rationalize it this way. Those that are home maybe don't work full-time jobs. Maybe they have more time to volunteer. But I didn't even ask the people who weren't home because they weren't home. Well, why aren't those people home? Well, maybe they're not home because they work full-time jobs. How would that change the sample percentage that I'm getting of those residents that are willing to volunteer. Well, if they work a full-time job, they may not be willing to volunteer because their time is limited once they get home. So when we put all that together, we've left part of the population out. And as a result of that, that part of the population we've left out may be less willing to volunteer. So this 60% of those who would be willing to volunteer that we obtained in the sample could actually be lower if I had included that part of the population which was not home. And so that's how we'll respond to that one. Okay, so let's take a look at what you would have needed in order to answer this question completely. First of all, the type of bias. You'll see that here. The type of bias is undercoverage. Next, you want to discuss what the undercoverage is and how that's related to the sample percent that was obtained, and that rationale will help you determine whether or not the true population percent is actually higher or lower than that obtained in the sample. So because of undercoverage, we've left out those who work full-time hours. The connection. As a result, their responses have not been considered and they may not be willing to volunteer. So we perhaps would have had more people to say no, bringing that 60% down. So the actual population percent may be lower, which means the sample percent may be higher. Now, there's a second school of thought. Think about who is going to the neighborhoods asking these questions. This is a church group, and they're trying to promote volunteerism. So think about what would happen if a church group came to ask about volunteers. Because they are affiliated with a religious group, the idea of doing good, being a good citizen, being a nice religious person may change the responses of those who weren't willing to volunteer to say, yes, sure, I'll volunteer, because they don't want to be seen as an immoral person or a bad person. So that percentage could have been elevated due to the affiliation that these people had, and by these people I mean the group that was going to the community, that these people had with a church. So let's take a look at how we could word that one. Okay, same idea. This sample suffers from, you could have addressed it as response bias or interviewer bias. The fact that the group is affiliated with the church may cause respondents to agree to volunteer. This is because the residents may not want to be viewed as bad people. As a result, the sample percent may be higher than that of the population. Okay, on to the back, question 3. We discussed this one in class, so I'll go through it relatively quickly, at least part A. Each state conducts an annual study of seatbelt use by drivers, following guidelines set by the federal government. Seatbelt use is observed at randomly chosen locations at random times during daylight hours. The locations are based on counties within each state. In Hawaii, the counties are the islands that make up the state's territory, and the survey is conducted on the 4 most populated islands: Oahu, Maui, Hawaii, referred to the Big Island, and Kauai. The sample sizes on the islands are proportional to the amount of road traffic, so each location is equally likely to be selected. Question A. Is this an SRS of road locations in the state of Hawaii? Explain. The short answer is no, it's not. The fact that they left out the less populated islands automatically denounces this as a simple random sample. A simple random sample would give every group of road locations the same chance of being chosen, regardless of what islands they may or may not be on. So, for example, I should have been able to select, just by random chance, islands or roads that are on the islands not mentioned. And that was not an option here. They only looked at roads from those islands. Remember that a simple random sample, again, gives every group of the same size, every sample of the population, the same chance of being chosen. Okay, let's take a look at what we have. First of all, the answer is no. This is not an SRS. The rationale, the thought process is to think about what an SRS is. It's a simple random sample. We explained what that means. So let's talk about why that definition is not met here. An SRS would give each sample of roads, regardless of island location, the same chance of being chosen. Also, the fact that I took a random sample of roads from each of the islands makes it impossible for all of the roads to come from the same island, which could also happen in a simple random sample. So for example, selecting all roads from the island of Kauai was not an option. Lastly, let's take a look at Part B. Suppose there are 476 possible road locations on Kauai, and we need to randomly select 22 of them to be in the sample. Beginning at line 120 in the random digits table below, choose the first 3 road locations for the seatbelt survey sample. Explain your method clearly. In explaining our method, we want to make sure we use 3 steps. Label, table, identify. Label, we want to make sure we assign roads labels from 001 to 476. The reason we're using 3-digit labels is because we assign those labels based on how many are in the population. Many students did it based on how many were in the sample. You have to be really careful with that. Table. Begin at line 20. Read numbers in 3-digit groups. Ignore numbers outside the labeled range as well as repeats. Choose the first 3 numbers that meet these conditions. Notice how concise yet clear this protocol is. Anyone can come behind me, follow those directions, and come up with the same numbers as I did. Identify. Locations 354, 239, and 421 will be the first 3 of 22 observed. So I want to walk through and show you how we would use this table. So we're going to break it up into 3-digit groups. So I've done that for you. So the first 3-digit number we get to is 354. 354 falls within our range, so we'll choose that number. The next number I get to is 765. It is not in our range, so we will not choose it. Next, I get to 597, also outside the range. Then there's 239, which is within the range. Then there's 421, which is also within the range. Since we were only asked to choose 3, those are the 3 numbers that will be observed. Feel free to watch this video as many times as you need to. Be sure that you have your actual skills check in front of you so you can compare my responses to yours. Remember, the goal is to use the time before the test to bring your responses up to complete. Right now, many of us were at minimal or developing, so please make sure that you take this seriously. Read your chapter, watch the videos, be ready for your tests. Feel free to post any questions you have on Edmodo.